Okay, welcome back to this day one of building the Oasis. I'm super excited about this, and at the same time, I feel kind of skeptical, but we'll see just how far AI has come. So, in this first day, what we'll try to do is just get a basic rendering engine up, and with that, we'll have the foundation for building various things like getting characters in, getting a wallet up running, and just trying out stuff. So, let's get to it. I've here created a directory called Oasis, and I'm just going to start Claude and ask it. Yeah. Well, actually, let's do init first because I haven't done that. Actually, while we wait for that, let's just go over here and do. So I think the first thing we really want to do is just get a basic rendering engine up running, maybe with a box in it. I have downloaded some more advanced stuff, but I still feel kind of skeptical towards how fast this is going to go. While there are all these rumors of things just running completely by itself, in my experience, these systems still make horrible mistakes and sometimes completely detrimental. So we'll see how far we get with this. But it shouldn't stop us from trying at least. So let's just go here and so I think one of the things I definitely want to do is I want to finish my work on one-up code, because answering these questions where you answer yes to everything all the time feels super unproductive. Like, I basically get nothing done. I just have to wait for this one to do its thing, and then yeah, press yes. But what we have done yesterday was we made a little document in the Claude desktop app, and whoa. So, right, okay, so it's trying to read these files. That's very optimistic. I would have expected that it knew what kind of file that is. Okay, anyway. Yesterday we made a document where we decided on using Bevy for the rendering engine. So this is based on research done by the AI, and so the whole premise of this project is that as much as possible, the AI should be doing all the work. I don't really want to do things, because if I have to do too many things, you can't really argue that there's a lot of singularity here. And really what we want to do is we want to show that we can do this without any human coding whatsoever, and preferably just with giving it some instructions. Okay, so let's set up some stuff now. Let's see. It's going to write. Okay, so we need to make the Oasis from Ready Player One. We will want to implement the rendering engine today and just load a simple model. Let's see what happens when we do this. Yeah, let's do Rust plus W GPU. Definitely. Yes, use the wizard. Absolutely. Now we want to use Bevy, and then we also have a Oh wait, what is it saying here? Yeah, just go for it. So we want to use Bevy as the library we are using for this, and we want to use a few other things. So it has some suggestions for the engine we should be using. Oh no, not this question again. That one is going to come up a million times. Oh, bloody hell. I forgot to change the title of the live stream. I wonder if I can do that while we are on the go here. Let's see. Okay, so what I'm doing here is I'm just asking it to use a small MCP server that I've been running now for a bit of time. So this is MCP server that helps Claude generate a plan and in a structured way such that it's easy to work with. Because it seems that it just chose to completely ignore the instructions in the Claude.md file, which I guess can go to show its autonomy, but maybe not so much ability to follow instructions. Okay. What does it say? Request permission. Yeah, let's just do that. Okay, and now it's using it. Do you want to proceed? Okay, let's just give it some instructions at this point because yeah, let's just proceed. See what happens and then ask it to revise. at some point it should ask us some questions about what we want to do. Yeah, just don't ask again. Who's the primary users of the rendering engine? Okay, so in the long term, this is going to be the end users. We would want the rendering engine to be completely programmable with custom models. See. Oh, however, why did it do that? Yeah, just go ahead and do that. Short term. Okay, so it's just asking whether we should support a bunch of things. I think we should use Bevy, but please research this. No, actually, let's just go with Bevy. We can always refactor later on. That sounds good. I think, yeah, we're going with Bevy, and then also note that in the short term, the target users will be developers, but keep a long-term vision in mind. Yeah, so I've guest passes for Claude. Do my day job while we're doing this. Oh, we're ready for the next question. I see. Maybe it's a good choice. It has built in blah blah blah. For the camera controls, what specific behavior do you need? Well, we need to have support for haptic suits, obviously, but maybe that's a bit ambitious for starters. So let's just do with mouse plus WSD. Zoom with scroll. Yeah, something like that. And now, okay, so what does it ask now? What should be the initial camera position? How should I know this? I mean, I'm not that technical. Should the camera start at a preset distance looking? Should it spawn a specific position in the world? Well, okay, actually I do know this. Let's put the camera behind the wizard and then make it such that the wizard on camera moves as we use the controls. That seems reasonable. What environment should be ground plane, skybox, or just a simple color background? Yeah, I guess there should be. Well, put some basic put some basic plane there. That's what we want to do, right? We want to have a ground plane and we want to be able to see that we can move around. Put a ground plane, a skybox, and some basic lighting. We need to be able to see that we are moving. Are there any performance constraints? Should the engine maintain a minimum frame rate? Well, okay. So this is where it gets interesting, right? We, in the long term, we want 60 FPS on modern hardware. And in the long term, we want to have VR XR support. No, it should definitely not exit. Okay, show a placeholder and an error message. I think in the long term, we probably want to have a distributed file system for these models, right? That seems to be the right way we could do these things. And so if we would have a file system, so I saw a really, really performant distributed file system for us the other day, and I think that would go very well hand in hand with this whole blockchain aspect of things. Yes, that sounds good. Let's use the latest. Oh, we actually didn't answer the second question. I have enough information. Okay, yeah, just go ahead and do that. So I think one of the ways in which coding is going to change in the future is previously we've been working from a principle that code is king. I think in the future it's going to be spec is king, right? So we need to have very comprehensive documentation of what we're trying to do. And this is going to be the new high level programming language, right? Writing good specs that the AI can understand. And so what we're going to experience in 2026, I believe, to be how are we going to arrange these specs and how are we going to manage them in a way that we are efficient and get predictable results every time. So this is one of the key things that I'm teaching at Compound Coders, namely the idea of doing precision prompting. We need to be able to be very, very specific about what we want to have. We want to be able to test whether we have gotten what we want. We want to be test driven. And so this little MCP server I've written here is built up around all of these principles. So what it actually does right now is it's creating a set of requirements. And if we go to the Oasis here, we look at the workspace, you'll see that it has a bunch of different things here. We just do a tree. You see it starts writing out the requirements for each of the things we want to have. And it has the feature, it has some answers that we gave to it. And then in time, these ones are going to end up in the spec. Okay, so the first requirement is model with PBR. I have no idea what PBR materials are, but it's probably great. Yes, that looks good. Looks good. Escape to exit, that seems a bit easy to exit, but fine. We can refactor that later. Ground plane, blah, 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 blah. Yes, let's approve this. So now we've approved that we've approved the requirements, and the next thing we are going to do is we'll go into the phase of creating the design documents. And so with that, it should now start. Oh wait, no, it's going to go into the use case phase first, which is about what is the user experience we're going to get out of this. And then after that, so you'll see we can go through every time we've completed a phase. We'll be able to go through what it actually did, and we will see that the requirements has ended up in the specs now. And the next thing that's going to happen is it's going to map out the use cases in the staging environment, and then once it's done that will be moved into the specs. So maybe if while we wait here for it to finish, let's have a look at what it actually does here. So we just do less specs requirements, and then this one. You'll see here it has a lot of metadata about the document, what feature this requirement belongs to, and then a bunch of functional requirements, some initial Rust API, and so on and so forth. And so one of the key ideas behind all of this is that as we move forward, we're going into something really complex, and we want to automate as much as possible. And so once our project here becomes complicated enough, we're going to lose complete track of everything if we're just letting the AI loose. So we need to have very, very strict tracking on what requirements came from where, what was the decisions that were made, and all of that. And so this MCP server is keeping track of all of that, and at the same time trying to link it to the files that are being developed. Okay, and we're just going to approve this because why not? I'm not sure I could be bothered to actually read the use cases. But in theory, I should. But in practice, I'm not going to. right, let's see. We now starting to design the components. And so it defines what are the model loaders that we are using. And it should be interesting. All right, we are done designing the components. Let's move on and approve that. And so you may think that we are doing too much design here, but I think one of the things that I've experienced is that the more context and the more accurate you could do it for a specific requirement or specific feature in such a way that it's easy for the LLM to find it, the better your output results you're getting. And that's exactly what we're trying to do here. Okay, does this design cover all these? System architecture, plugin graph, data models, comprehensive, blah, 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 blah. Should actually be pretty interesting to see. Let's just have a peek at this. I'm kind of curious what it's come up with. Let's do a tree here. Trees is in the specs. No, it's not in the specs yet because we haven't approved it. It is right here under staging, designs. It's going to do less. Okay, and so you can see here the traces. It keeps track of what requests it keeps track of what requirements are required here, use cases and components. So all of that is covered. Then we have a system architecture here, which describes exactly how it envisions that the system should work. I'm not going to argue with this. It might be right, it might be wrong. I have absolutely no clue. Well, actually, I do have a clue, but I choose not to in the context of doing this as ripe as possible. But the point here is that we get this really, really nice, relatively condensed document, right? So if we do VC on this one, you'll see it's only about, wait, which one of these ones is the lines? I think that's the 300 something. Yeah, 335 lines, which is probably translating into just about 5,000 tokens. And so this is a relatively small thing for the context. Now, what this makes is we can take this high-level architecture, put that into the context together with the specific thing, the specific component and the requirements for that component that we're doing, and we might end up with a context of 20,000 tokens, but everything is so clear because we have very, very specific documents for each of the things, and we can now cherry pick these ones when we're going to build out our things. Okay, we're going to approve this. Look great. Again, have to remember non-developer in this context, so I'm trying to not have too much of an opinion about how things should be done. After all, if I have to do things, we are arguably not at the singularity, and I still have a job, which is great. But on the other hand, I do want to live out this dream of living in a virtual world forever. Um, that could also be pretty good fun. Cool. Now we're getting to the good part. We are creating the test specifications. The test specifications is what we'll be using for creating our unit tests and our integration tests. And this is a very crucial part of how we are operating this whole thing. Because the way to ensure that you get really good results is that you make sure that everything is tested as much as possible. So this is one of the reasons why we're using Rust, because it removes a ton of runtime errors that we otherwise would have to track down afterwards. The second thing we're going to do is we're going to implement a ton of tests and aim for very, very high test coverage. It will not make sure that we are rid of all our bugs, but it will take a very, very large portion of it out that we have done this up front. And since we're not doing anything of the work here, it's actually a relatively low burden to do. Right, let's see, we're going to just accept that. And so it has decided that we should have a couple of unit tests and some integration tests, and then some more unit tests, some more integration tests, and so on and so forth. Again, I'm not really going to argue with this. It just has to do it. Okay, this was a lot of writing. And now we are starting on the implementational phase. Let's just go back here and have a look. If we do the tree and the spec, we have this whole thing. Let's try to just do so some 3,435 lines of lines of context and about 85,000 characters, which means that we should be really, really well off at this point in terms of having answered all the questions. So there should be very little room for the AI to deviate from that path as long as it sticks to the specs we have come up with. And as long as those specs are consistent with one another, we really should have nailed down that it will take a very certain direction. Interesting. So it seems that it's gotten the idea that this should be a 3D wizard rendering engine. I thought we had been pretty clear about what the Oasis was meant to be. The wizard is basically just something we have there as the first object we are going to render. So this makes very little sense to me that it's this comment. And it does raise some questions as to just how ready these LLMs are for really providing a singularity. Like, there's no doubt about that we are being faster than we ever were. But my hypothesis is that by the end of 2026, what everybody will be doing is exactly what I'm doing now, with writing out very clear specs. And specs are going to be the new programming language, the same way that high-level programming languages replaced assembly, and the same way that assembly replaced punch cards. Right. I don't think that anything is going to change that. It's just going to lower the barrier. I don't think we will see an awful lot of singular behavior. But, I might be wrong, and maybe this turns out to be the pipe dream. We're just going to get the entire Oasis built up without having to do anything for it. I mean, so far it's going pretty smooth, right? We got all of this documents and stuff. So, maybe it is going to end well. But probably it's going to be the same story as it was with self-driving cars. That, yes, a Tesla is nice to drive in, it helps you a lot, but arguably it's not really self-driving, at least not in Europe, since you still need to do quite a lot. And if you look at Waymo, they still need to have all of these extra things, and in order to actually do the job. It's going to be way different from what we anticipated, and also the timeline is going to be longer. That's my prediction. But again, assuming that we are hitting the singularity just right about this month or maybe the next month, I might be completely wrong. And we have to entertain that idea, which is why now is the time to start a really ambitious project as a solopreneur. So, and I maintain if a single person can build out the Oasis, then arguably we are very, very close to something like the singularity. The real question, though, is the code quality going to be good? Is it going to be maintainable? What else can we learn about vibe coding through this project? I think there's going to be a lot of learnings in all of this. Why does it do this now? Description. Oh, wait. Okay. Okay, and so now it's done with the implementation. It has ran it's done the implementation. It's built out the tests, and now it's actually running the tests to see that it meets the standards that it's supposed to meet. And again, this is part of the framework that I'm building out here and teaching on compound coders on that you should be very, very careful. First, building out your project requirements, and from that, making sure that there's good context. And then from that point, you start to automate little by little, and then you run it for tests, and then you go back, you fix everything that's broken, and then eventually you run some more tests and some more evaluation just to make sure that everything is right. Also, the other thing that I'm really interested in is how long is this project actually going to take? So I've planned for about 300 days of work here, spending about 1 hour every day on just getting it to do random stuff, like building out the engine. We'll eventually need to shard the universe and make sure that everything is nice. We'll need to build up a decentralized network for the traffic. We'll need to work out how we store the assets. We'll need to integrate chains and all of this. And so we should. Oh, right. Let's just stop here. So you see, now it looked at the test coverage and it figured out, well, actually, we're only doing 15% test coverage. So it's getting back and saying this is below the threshold. We're going to work on this and get it to work better. We're going to implement more tests. We're going to test this better just to be sure that we actually have covered as much as we could upfront. We know what the requirements are. We know what the user stories are. We know what the design should look like. So there should really be nothing surprising here. And all we need to do is look at the code and figure out which paths haven't we tested and why haven't we tested them. And then go back, write the test that that path works as exactly as it should. So there's nothing really magical here. And so my only concern about this is that it might end up writing way more tests than what is actually needed. But again, this is something that time will tell. And also, 100% test coverage is not the same as saying that the code is bug free. Any good software developer knows this, but it is definitely a step in the right direction. But we might very well have a fundamental design issue in the design documents. And so, if there is a specific behavior, we can go back to the design documents. We can now look at these ones and say, well, is there anything here that would be a reason for the bug? And then once we have reasoned about that, we can work our way down from the docs all the way to the actual implementation. And with that, you have the possibility of then either fix this on a spec level or design document level. And the nice thing about this is that since we're keeping everything in Git, you'll be able to pick this up as part of your CI project and say, hey, the specs changed. Does the implementation actually match the specs here? And this is kind of the next level of CIing, that you have these spec documents, and we can now compare the specs, or we can compare the specifications to what is actually implemented and say, are we meeting the objectives here? Which is a completely new thing. So in one way, you can think of this very much like what we're doing with modern Kubernetes infrastructure, right? So you're keeping all the manifests in one repository, and then the state of the system is basically replicating what that is, and you can compare the two to see if there's any differences, and then patch. Now we're back to running the test and verifying the coverage. And so one of the things you'll notice here in the way we're developing this code is I'm actually doing very little. I have barely been doing anything except for answering a few questions and then saying approve. The rest is kind of running by itself here. Well, at least if you say for all the ridiculous questions I have to answer, whether I want to run this command or not. We'll address that in another video. So I'm working on an open source project called OneUpCode. So that will nicely sandbox everything while still allowing us to run Claude code and NPCs and all of these kind of things. And just it aims to give a better developer experience. But it's very early stage at this point, so it's still quite buggy. Therefore, I didn't want to show this in a live stream yet. But it's coming. So wow, this is so typical Claude. Will you look at that? So I couldn't get to 90, so I'm just going to change. Oh, for fuck's sake. So I'm just going to change what the requirements are, and I'm not going to ask the user about this. This is just ridiculous. That's a good screenshot for later. Okay, so, well, at least what we can make from this is that probably having hit the singularity is a truth with some modification. This is yeah, definitely a non-great way to ensure that we are meeting the criteria. Also, I'm pretty sure that I specifically have written in the Claude thingy that it should not. Right. Never directly modify any files in the AUP managed directories. So it completely disregards the rules. This is so hilarious. So you can see here it chose to update this config despite the fact that we told it it's really not allowed to. And this, well, I mean, we might have hit the singularity, but you can forget about safety because the AI is just going to do whatever the fuck it wants. Completely not taking the Claude.md into account. This is ridiculous. Okay, this is getting a bit boring. It's spending an awful lot of time running and verifying tests. So I think let's just see if we can run it and just check out what happens. Okay, what does it want to do? I want to access my microphone. Okay, let's. Okay, let's just see. Right, so it's done something here. Oh, we actually do seem to have something that looks like a wizard, but the zoom is a bit off. But this actually looks kind of like the model that we have. What happens if... Okay. Let's just see. Okay, I feel like we need to just make a few changes here. Okay, let's just have another look here. Oh. Okay, so you'll see here, this is the model that we actually downloaded. And if we look at the model here, we can see that there's definitely some of the right stuff being loaded here. And so it might just be that the camera is placed inside. And then there is something with the controls that are not quite as I would want them to be. Okay. So I think what we're going to do at this point is just stop the stream here, and I'll let this finish off, and we'll see where we are on Monday. Until then, have a great weekend, everyone, and take care.